Good afternoon, good evening. It's your boy Mr. Malaji, and I'm back with another video. And in this video, we're going to be talking about how do we find, or rather, how do we use the compound interest formula in financial math. And particularly, this happens, this is specifically for when we have these different compounding periods. So what is the implication in terms of the compound interest formula? So let's look at the compound interest formula. This is our generic compound interest formula, right? But remember that if you're told that a compounding period is, for example, twice or semi-annually, or if you're told that it's daily, or if you're told that it's monthly, then this formula will slightly change a little bit. And these are your options. If it's daily, then this is the rate that you would divide with 365. Then if it's weekly, this is the rate that you would divide with 52. I'll explain it just now. What do I mean by divide? And if it's monthly, this is a common one, monthly, it will be 12. And if it was, what's a common one as well? Semi-annually or biannually. Semi-annually or biannually. Then you'd be dividing by 2. And then lastly, if it was quarterly, that means it's happening, this rate of interest is being accumulated every 3 months. And so for that, we'll be dividing by 4. So these are the rates. And so what does it mean? It means we're going to take the same formula that we are working with, but then we need to remember to divide the I with the compounding rate and times the N with the compounding rate. But before maybe I unpack what the M and the N and all of those guys are, let's talk about the A. The A is this final value that we find after investing money. So this is the money that we find at the end of our investment period. The P is the initial money that we are investing. So this is the money that we actually put into the bank. The I is your interest rate, right? This is your interest rate, and remember it has to be either in a percentage or a fraction, or you can even put it as a decimal, but you can't just write 10 as 10%. You have to write 0.1 for 10%. And lastly, the N is the number of years. And what does the M stand for? The M is our compounding rate. Yes, so that M will change depending on what we're talking about. If you're talking about daily, then we'll be dividing by 365 and timesing the N by 365. If it's weekly, we're doing the same. If it's monthly, same. It's just that these values would obviously change. I hope that makes sense. So, how do we apply all of this to a question? All right, so in this question, it reads that David invests 50,000. So let's highlight the important parts. 50,000 at 8% per annum of compound interest. So it tells us we definitely need to use the compound interest formula. The question then reads, what will his money grow to in 5 years' time? And it gives us different compounding rates if it's compounded annually, if it's compounded quarterly, or if it's compounded monthly. So let's do each of them. So I'll whip out my compound interest formula, right? If it's compounded annually, that means there is no fancy divisions that needs to happen to the I. So it'll just be 50,000 plus the compound interest rate. I'm going to put it as a fraction, 8 over 100. And the exponent will be the 5 years. This 5 years that we have here, which is the n. And then you just plug that into your calculator. And so your accumulated after 5 years will be 73,600 and 466.40. So that will be the accumulated after 5 years. But then how will this formula change slightly if you are doing quarterly? So yes, we're still having 1 plus I to the power of n. But remember, since this guy is compounded quarterly, still the same 50,000 is being invested. But now we have 8 over 100 divided by a 4. And remember, 4 is our compounding rate for quarterly. And then our exponent will have the 5, the number of years, times the 4. And the rationale there is that if it's compounded quarterly, that means it's 4 times a year in every 3 months. So 4 times a year times 4 will give us 20 times in total. And again, you just plug in that whole thing into your calculator, and this means you're going to get 74,297.37. And take note, this amount is smaller compared to this amount. And why? It's because now the interest is being compounded regularly, or rather quarterly, every 4 times a year. Then this last guy, since now we are told that it's compounded monthly, again, we're going to do the same calculation, 50,000, but the only difference is that now our 8% is now going to be divided by a 12. That's what monthly means. And then again, the 5 is going to be times by a 12. And if you plug that in to your calculator, exactly as you see it on the right hand side, you should get that this is 74,492.29. Again, these values are increasing in the sense that if you're compounding something monthly, you'd obviously get more interest out of it. If you compound it quarterly, you'd get more interest compared to annually, but obviously less compared to compounded monthly. And again, if it's compounded annually, that is the least amount of interest that you'll get. I hope this makes sense. Let's try the same idea, but now let's look at how would we find the principal amount, the P, the initial amount that is invested. All right, question number 2 is a beautiful question. It reads that Lisbeth invested an amount of money 10 years ago at 6% per annum compounded semi-annually. So already I'm thinking about what do I need to times or divide with there. And her money is now worth 37,189.01. And the question is, how much did she invest to start off with? So again, it's compound interest formula, which looks like that. Remember, the P there is your initial amount, and the A there is your final amount after the investment. So since we already have this value here, this is our final value. And the number of years is 10 years, it's given here. That's our N. The I is the 6.5. And now the question is, what are we trying to solve? We're trying to solve for P. The P is what we're looking for. So let's substitute. 37,000 comes this side. on the left-hand side of the equation. The P is unknown, 1 plus the 6.5 over 100. But remember, he's compounded semi-annually. So we're going to divide it by 2. We're going to have how many years? 10 times the same 2, the compounding rate. This is the same 2 that I'm dividing the I with and timesing the N with, the number of years. Then how do I possibly solve for P? To solve for P, I just need to divide by this bracket on both sides. So I divide by that bracket, which is a 2. It has an exponent of 2 times 5 times 2, or 10 times 2. And this side, the same bracket. And you're probably watching and you're thinking, but why? Why are you dividing by that bracket on both sides, Mr. Malaji? Because the reason is that's the only way to cancel that bracket there. Just so P is isolated by himself. And therefore, P is equal to this big expression here, which is 37,189,01 divided by the bracket 1 plus 6.5 over 100 divided by 2 to the power of 10 times 2. And if you plug this into your calculator, you should get that he invested, to start off with, a rounded off value of 20,000. And there we go. So that's how you would go about solving for the P using your compound interest formula. Hope that makes sense, guys. If you want to have a look at it and pause and rewind, you're more than welcome to do so. I'm therefore going to move on to question 3. And in question 3, we're going to look at what happens if we're actually trying to find the actual interest, the I. How do we go about solving for that? Number 3 reads that Tulani borrows 2,000 Rand with the agreement that he will pay it back as 3,000 Rand exactly 2 years from now. Calculate the interest rate charged per annum compounded monthly. So now we are in fact looking for the I. What does the question give us? It gives us the amount of money he invested, which is 2,000. It gives us what it grows to, or what he's going to pay it back as, which is 3,000. It tells us that the N is 2 years, so you're going to pay it exactly 2 years from now. The question is, what is the interest rate? So again, we employ our compound interest formula. We substitute. We have 3,000 for the A. We have 2,000 for the P. 1 plus the I. I can't just write I by itself. I need to divide them with this compound rate, which is 12, remember? And then the N is a 2 that is also going to be times by the same 12. Again, this 12 that I'm dividing with and timesing with is the same value. Then how do you possibly solve for this? You divide both sides by the 2,000 that is outside of the bracket. And if you do that, these 2,000s are going to cancel. And now this side, you can simplify this fraction. It's actually a 3 over 2, which is equal to a 1 plus I over 12 to the power of 24. How do you get rid of that root? You 24th root on both sides. How do you get rid of that exponent? Sorry, you 24th root on both sides. And so the root and the exponents are going to cancel. Now you have the 24th root of 3 over 2. And then the 1 is also going to go over, and so it's going to subtract a 1. and this whole thing is going to be times by this denominator of 12. So you times by 12. And this is what I is equal to. So if you plug that into your calculator, you should see that the I that you get is a 0,2045. But that guy, as a percentage, you times them by 100, is a 20,45%. And there we go. So that's how you would go about calculating the I. Then lastly, let's look at a question where, what if we were trying to calculate the N in this case? What if the N is the guy that is unknown? How long do you have to invest something for it to grow to this amount? Let's look at that question. All right, then finally, the last question says, how long will it take money to triple in value if the interest rate is 10.5%? And now the question is, what is the N? So clearly we're looking for the N, the how long. What do we have as the principal value? We're not given what the principal value is, but we know that it triples. So we can assume a principal value. I don't know, we can take 100 as the principal value, and 3 times of that will be the accumulated value, which is going to be 300, right? And the question is, or rather the interest that's given is a 10.5 over 100. Remember, you need to either write it as a fraction or write it as a decimal like this. This is how you write it as a decimal. All right, so let's use our compound interest formula. There we go. And now take note, we're trying to solve for n. So we have the 300 there. We have 100 there. 1 plus the 10.5 over 100 that is compounded. This time, this said this guy is compounded daily. So daily is 365. And that n there is also going to be times by 365. Remember to not forget to do that. So if I divide by 100 on both sides, to get rid of this 100, those cancel. Then I'm left with a 300 divided by 100 is just the 3. With this bracket here, 1 plus 10.5 over 100 divided by 365 to the power of 365 and n. And how do you possibly solve for that n that is in the exponent? So what we're going to employ is we're going to employ logs. This is how you use logs. It says if I have a is equal to b to the x, and I'm trying to solve for x, then it's the log base of the b with the a being there, and this is all equal to x. Take note, the x that has the exponent, or rather the base of the x, where the exponent was, becomes a base this side. So let's apply it in this question here. I'm not going to evaluate those brackets. I'm going to leave them as is. It's the log base of that fraction, this expression here in the brackets, divided by my 365. And then the 3 will be here. But take note, this whole guy gives me 365n. So how do I get n by himself? I need to divide by 365 on both sides. So this is also being divided by 365. So our n is essentially equal to the log base of this expression divided by 365, with the 3 being the guy here in the middle, and this whole thing is being divided by 365. And if you plug this into your calculator, you should get 10 years, 0.46. So if they wanted in just years, you would leave it like that. But if they want the months, you would take the 0.46, the decimals, and times them by 12. And I think if you do that and you round off the guy, you should get that this is 6 months. So it's 10 years with 6 months. And there we go. So that's how you work with the compound interest formula, and specifically for each case where these guys are compounded, it has a compounding rate. I hope that makes sense. In the next video, we're going to expand on what is the implication on depreciation, what is the implication on inflation, and all these nice things. I'll see you in the next video. Bye.